In the Second World War, Allied intelligence needed one number. How many tanks was Germany building each month? Spy networks said around 1,400. A handful of statisticians, using nothing but the serial numbers stamped on a few captured tanks, said 246. After the war, German production records gave the real answer, 245. This is that formula, and the story of the one assumption that can silently break it. Here is the setup. German factories stamp parts with sequential serial numbers, 1, 2, 3, up to N. N is the month's production, exactly the number the Allies wanted. Capture a few tanks, read their serial numbers, and estimating the size of an entire tank fleet becomes a statistics problem. Take a concrete campaign. We simulated a fleet with its true size hidden and captured 5 tanks. Their serials, 74, 124, 240, 616, and 920. The largest serial we saw is 920, so the fleet has at least that many. The question is, how much bigger? First instinct, just report the biggest serial you saw. But the maximum of a sample can never exceed the truth, so it is biased low by construction. Across 100,000 simulated campaigns with a true fleet of 1,005 captures each, the sample maximum averaged 834. It undershoots by about 17%. The fix is a symmetry argument. Your 5 serials cut the range from 1 to N into 6 gaps. On average, all of those gaps are the same size, roughly the maximum divided by K. The unseen space above your largest serial is, on average, exactly one more gap. So add one average gap back. That gives the estimator, N hat equals M, times 1 plus 1 over K, minus 1. Take the largest serial you saw, stretch it up by one average gap, and subtract 1. Statisticians call this the minimum variance unbiased estimator. No other unbiased formula built on these serials has less spread. Apply it to our 5 captured tanks. 920 times 1.2 minus 1, an estimate of 1,103. The hidden truth was 1,000. 10% off from 5 data points and 1 line of arithmetic. Don't take one lucky example's word for it. Measure the estimator. We reran that campaign 100,000 times. The serial number estimator centers exactly on the true 1,000, with a standard deviation of 169. The natural alternative, doubling the average serial, is also unbiased, but far wider. Standard deviation 257. The gap logic wins. So with only 5 tanks, the formula is unbiased, and a typical campaign lands within roughly 17% of the truth. That is the precision the Allies were working with, extracted from scrapyard serial numbers. Now the real war. For June 1940, the serial number method estimated 169 tanks. Intelligence said 1,000. Captured German records later showed 122. June 1941, statisticians 244, spies 1,550, records 271. August 1942, 327, against 1,550, records 342. Month after month, the formula was close, and the spies were not. Average from June 1940 to September 1942, the serial number estimate was 246 tanks a month. Conventional intelligence said 1,400. Albert Speer's captured production records showed 245. The statisticians missed the truth by 1 tank a month. But here is the part most retellings skip. The formula's guarantee rests on one assumption. The tanks you capture behave like a random sample of everything produced. Every serial equally likely. Nothing in the arithmetic warns you when that stops being true. So we broke it on purpose. Same formula, but now all 5 captured tanks come from a single production batch of 150 consecutive serials. Think 1 convoy from 1 factory shipment. The estimates collapse. The average answer drops to 659 against a true fleet of 1,000. A silent 34% underestimate, delivered with full confidence. This is not just war history. Sequential IDs leak the same way today. Order numbers, invoice counters, software build numbers. The estimator still works until your sample secretly comes from 1 cluster. Then the math stays confident and wrong. 3 things to keep. 1. The estimator is gap logic. The largest serial plus 1 average gap. -1. 2. Trust it because it is measured 100,000 seeded campaigns, zero bias, and it clearly beats doubling the mean. 3. Before you use it, interrogate how the sample was collected. This formula beat every spy in Europe. The only thing that beats the formula is a sample that was never random.